Hello, and thank you for viewing this video presentation on PHA facilitation. The specific PHA methodologies I will be focusing on today are the HAZOP and LOPA PHA methodologies. There are, of course, other methodologies out there. These will be covered in subsequent tutorials, but once again, today's focus will be primarily on HAZOP and LOPA. My name is John Johnson. I am a senior engineer here with Nebula Safety Environmental. I am a chemical engineer by education, and I've been focusing on PHA facilitation as well as other safety and environmental focused topics for the last 9 years. So today we are going to be looking at what a HAZOP actually is, why you need to conduct PHAs for your facility or regulated process, how one goes about preparing for a HAZOP or LOPA study, and this is both from the facilitator side as well as what the facility should also be preparing for and expecting, tips on ways to streamline the overall HAZOP and LOPA process, as well as what kind of post-session documentation should be developed, how long it should be kept. These are the kind of documentation that will be requested by regulatory authorities for your normal 5-year revalidation cycle, as well as if there is ever any sort of release or accident on site. One of the first documents that are going to be reviewed is going to be the PHA documentation. As I mentioned previously, one of the first topics I wanted to cover today was why you need to conduct the PHA in the first place. Typically, if you are required to conduct a PHA, it means you have a highly hazardous material, either a toxic or flammable, above OSHA's Process Safety Management Program or EPA's Risk Management Program's mandated threshold quantity. So, for example, flammable materials kept above 10,000 pounds in a specific process are considered applicable for OSHA PSM or EPA RMP regulation, and therefore you're required to cover a process hazard analysis, and this has to be done every 5 years for the life of the process. As I mentioned in my introduction, there are several different PHA methodologies that can be used, and different PHA methodologies work better for different processes. So as I mentioned, I am specifically focusing today on an overview of HAZOP and LOPA, but there are other processes out there. There's other methodologies, the FEMEA, the Failure Modes and Effects Analysis, the Overpressure Risk Assessment, which is used to meet JAPSA 525 requirements in Canada. There's fault tree analysis, what if, like I said, many other methodologies, and a lot of it just depends on what the type of the process is, how complex it is, how significant the hazards that may be involved in the chemicals are, that kind of direct you as to what would be the best PHA methodology to use. One other point on that is for state mandated programs, typically you need to consult with your local regulatory authority and also allow them to provide their input on what methodology you should be using. These PHAs are basically used for hazard identification and analysis. Typically, they are a brainstorming session where a team of experts on the process and on the equipment used in the process can get together, have a discussion, brainstorm possible hazards, identify potential safeguards, and develop, once again, a qualitative risk ranking using an agreed upon risk matrix to determine the overall risk level, and then come to determination as to whether or not that risk level is acceptable. If you work in the chemical industry, if you work in the petroleum industry, there are inherent hazards with the material. But based on the safeguards you have in the system, based on the equipment, based on the expertise, you really want to kind of put together a qualitative look at what the overall risk is. There's always some sort of risk, but you want to make sure that the company you work for, the facility you work at, has identified what we call an acceptable risk tolerance. And if you come up with a scenario and you are out of that risk tolerance, well, then typically you're going to make a recommendation to lower that overall risk till it's within tolerance. And as I mentioned before, we're also going to look at layer of protection analysis. Layer of protection analysis is considered a semi-quantitative analysis, and we'll get over into that in a little bit. But typically we want to use a LOPA if we do identify some, fairly hazardous high-risk scenarios via one of these other PHA methodologies, specifically for this presentation, the HAZOP methodology. I really want to drive home today how important a good team is to developing and performing a successful PHA. Team composition, you should have members who are knowledgeable in the process and methodologies. Typically, you want to have 3 to 5 members. I, of course, have been in PHAs with 25 persons in a room. I've been in PHA with only, 2 or 3 persons in the room. Typically, you want to make sure that you've got operations representation, engineering representation. In fact, operation and engineering representation are typically mandated by regulatory authorities, so you really don't have any choice on that. But I've also found having other subject matter experts, maybe not their full-time, but rotating equipment specialists, subject matter experts on toxics, on release case analysis, things like that really flesh out the team and let you perform an accurate study. As I mentioned previously, the HAZOP itself is a brainstorming session. So it, of course, is subject to the experience of the team at hand. So you really want to make sure if you want to do a successful PHA that really matches what can happen in the field, then of course you really want to make sure you have personnel who can adequately perform that task. Kind of a running joke I always have in my PHAs, and I am an engineer, of course, and so I always say that engineers know how things are supposed to work, and operations knows how things really work. Because there is a disconnect between what we see on paper and how we design to how it's actually run in the field. Another thing is you want to keep the disturbances down to a minimum. Once again, if you're doing a PHA for a working process, well, your engineers and your operators are in demand. You have to basically let them perform this PHA on their own and take them out of the field for sometimes multiple weeks. And so it can be hard. And so you'll be getting emails coming into the engineering. You might have questions coming into ops, but those disturb the overall flow of the team. And so what should be maybe a 3 or 4 day study can start ballooning into a 10, 12-day studies simply because you keep losing key personnel. Typically, we like to keep the PHAs around a 6-hour session. And of course, that's after, not including breaks and lunch and stuff like that. Just in my experience, I've found that 6 hours is a good time to keep the team focused. I, of course, have worked longer PHAs because, once again, the facility does not necessarily want to lose their personnel for multiple days, but I have noticed that the team quality does start to degrade after 8 or 9 hours. You just get tired. The brainstorming is no longer quite off the top of their heads. It's more just trying to say whatever they can to kind of close out the day. You want to make sure you do have access to those PHA team resources. Once again, you're not going to have a whole lot of subject matter experts available for every single process, and they of course have other tasks to perform at whatever the facility is. So they should just be available. You should be able to reach out to a rotating equipment specialist when needed, get a quick response so that you can keep the PHA team needed. As I mentioned earlier, lunch, it's not that I want a free lunch. I love a free lunch, but really providing lunch for your team does make the overall session work better and go faster. So what typically happens for facilities where lunch is not provided is that the team is obviously forced to go out for lunch. There's always that kind of lag time between getting the team back after lunch as well as getting them refocused while they're sitting and adjusting and taking care of things that were outside of the PHA study. So my suggestion is, if at all possible, if it's something you can do, provide lunch for the team, let them stay focused, let them focus on the task at hand, get it done quickly and efficiently. And finally, a technical scribe. So when we say technical scribe, that typically means someone with experience in scribing for engineering-based studies and hazard-based studies and things like that. Of course, you can have cases where I've scribed for myself for many PHAs, but it does take a little bit away from the conversation. And typically, once again, as this is a brainstorming session, you want to keep that conversation focused on the task at hand. If you have a good technical scribe, I typically use the same scribe for most of my studies. She is very adapted, kind of almost reading my mind these days. And as I'm having that conversation, able to quickly fill out the worksheets and get what is being discussed onto those PHA worksheets. And as I mentioned previously, those worksheets are going to be the lifelong documentation of that PHA study. So I mentioned previously that one of the most important components of doing a good PHA is having an adequate team. Well, something that else is very important is giving that team information that they need to accurately make assessments of the hazards in a process. So typically we'll send out a list asking for certain items that will help the team make their analysis more accurate to us in the field. So typically we're going to be looking for things like the cause and effect matrix. If you have safety instrument systems, we'd like to know at what point they trip. When they trip, what exactly do they do? Do they shut things down? Do they open block valves? Do they close safety valves? If we can know exactly what those safety systems do, well, that will go a long way into helping us ascertain what the likelihood of that event making it all the way to the worst case would be. We also want to look at the lock valve and car seal valve list just to verify that what's in the field matches what's on the drawings. Look at the critical check valve list. Check valves are notorious for failing, but if there's safety related check valves that we really need to make sure are doing their job in the field, well, they should be designated critical, and we should be able to at least look at that they're on a critical list, that they're being verified and maintained as part of the facility's mechanical integrity program. We also things like dead leg lists, previous MOCs. I mentioned previously that the PHAs are on a 5-year cycle. So the question is, well, why can't we just do one PHA and it lives forever and you don't have to sit there and put that team together every 5 years? Well, the truth is processes change. You might need more throughput, you might change out your pumps, lines go away, new lines are added. All these things change the process, and a lot of times on just what you would think is an insignificant basis. But collectively, those changes might add up to something that could result in a hazard. Many hazards that have happened in industry are a result of changing it from the original engineered design. Typically, if you just leave it at design, never change it, well, you should just be able to run the process as it was meant to be run forever with no issues. But of course, things change, and those MOCs provide the PHA team a way to look at those small, minute changes on a holistic level, look at the entire process, and see if maybe something was missed in the hazard review that most likely went alongside that MOC. We also want to look at previous incidents and industry incidents. That is simply going to provide feedback when we're trying to decide what the likelihood that a certain event may result in a significant and consequential release. Facility siting studies are always very helpful for the team. Let us know, someone else has already done a look at certain toxic release scenarios, how big it can be, how widespread the dispersion might be. Corrosion studies. If you're in California, a copy of the seismic study is very helpful for us to take a look at the equipment in the process. Access to relief valve design basis, especially if you're in the petroleum industry, there are a lot of cases of overpressure. And so we want to look and make sure that the relief valves, which everybody relies on the most, actually are sized for the scenarios at hand. Typically, there was a session in the design and, they identified fire case and some of the basic cases for relief valve. A lot of times the PHAs will identify 2 or 3 other cases that maybe were not identified in the relief valve design basis. So we want to take a look at that, see if they were identified, because if they're not, we have to make recommendations to add additional sizing calculations to those valves. Pump curves, once again, if we're blocking in on the discharge of a pump, well, you're going to deadhead that pump and you're going to raise that pressure. And we want to make sure that that pressure increase is going to be within tolerance of the vessels and equipment in that line. And same thing with access to UNA forms. That's going to give us a look at what the maximum tolerance on those vessels are. So once again, we know if we are building a pressure, how high we can go before we might have a very significant release case. So of course, it is 2021. We have been dealing with a pandemic for the last 2 years, and things have changed in the way we process and conduct these meetings. There have been a lot more remote meetings conducted for these PHAs. There was no break in safety in facilities, so regardless of whether your state or your facility was on lockdown, you are still required to conduct these studies. So we have had to adapt and come up with new ways to do these remote studies not in person. If I had to give my preference, I prefer doing these studies in person. I feel the conversations are a little easier to maintain. We can all look at the drawings together. We can look at the PSI together. But the world being in what it is, we've had to learn to adapt and perform remote PHAs. So this is a slide that just talks about some of the ways to approach these remotes so that you can get the same quality you would get out of an in-person study. You want to ensure that you conduct a remote trial session of the PHA prior to the real PHA. And this basically means testing your equipment, making sure all the team members have access to equipment. A lot of times we're using 2 monitors. You'll have one that's going to show the PHA worksheets, another one that might show PNIDs or PSI information. It does help the speed, so you can have the team focusing without having to close out one window, bring up the PNIDs, transfer it to control to someone else. And so before you even get them the first day, you want to test that out, make sure that everyone has access to whatever the remote meeting software might be, whether it's GoToMeeting, Microsoft Teams. Just make sure that everyone has access so you don't lose any time on that first day trying to get everybody calibrated. It is important because otherwise, if you have technical difficulties, trust me, they can really derail the study. Electronically highlighting the PNIDs is recommended. That is typically how I like to do it anyway. They're a little bit cleaner. They make for smaller file sizes, so they're easier to transfer from myself to members of the team. Also, electronically redlining the PNIDs as the team is looking at it on that second monitor is going to help out. There's always changes to a PNID during a study. There's always something that maybe an operator identifies that was not captured on the last PNID update. And so as we do these studies, we try to capture those. We call it redlining, and these days we'll just put notes on the PNID itself, the electronic version with the highlighting, and then we send that back to the team once the PHA is concluded. Each team member should have a copy of their own PNID set. Once again, if they don't have access to that second monitor so they can see the set I'm using. So a nice hard copy, even though we're working off of the digital, is nice. That's where I make a lot of my notes. I identify pressures, temperatures to be input into the software later. So it does provide a good place to provide notes and help the team stay aligned with one another. If you're the meeting organizer, you should have the ability to mute participants, which I don't use that very often. Trust me, I am very much about team consensus and having everyone participate. That is one of the first things I'll say in my meeting presentation is please interject, please. If it pops in your head, that is the very nature of a brainstorming session. Let it out, let the team hear it, and let's have a discussion as to whether or not it is a real case. However, there is a time constraint. We do want to get these PHAs done, and if there is, too much discussion that's not hazard related, a lot of times when we have these PHAs, we'll start talking about design and engineering. It's an easy trap to fall in. I am very curious. I love to know how these processes work, even outside of the hazard scope. But if we want to make sure these PHAs can conclude in a timely manner, sometimes we do have to mute one or two persons so that the dialogue can occur between some of the other team members. Of course, I'm not saying that the person who's muted input is invalid. It just helps that if we can get one or two people talking at one time, then we'll go back, unmute the other person, and see what they have to say and provide general feedback for the meeting. When asking questions, the PHA facilitator should also make sure to direct questions specific personnel. If you're using MS Teams, if you're using, GoToMeeting or something like that, I typically have another screen that just has the symbols of all the personnel. And so, of course, that's great because when someone's talking, I can see that highlighted. I know who I'm addressing. It helps me to identify who the operators are, who the engineers are, and so I know who to specifically call on as we have these meetings. I've mentioned this previously, but having a scribe makes a lot of difference in longer studies. It really helps to keep the team focused, allow the facilitator to have those discussions, and to quickly and accurately make notes in the PHA worksheets to accurately describe what was discussed in the study. They're able to copy and paste similar scenarios and consequences, update tag numbers and PNIDs while the facilitator is engaging with the team in determining the consequences. It really does save a lot of time when the team does not have to wait around for the facilitator to dictate this type of information. And that really is what happens, is the team comes up with the discussion, the facilitator then basically regurgitates it to the scribe, who would then type it in. A good technical scribe will be recording this information as a discussion occurs, and therefore most of the time I just turn around, I take a look at the monitor with the PHA worksheets on it, realize that my scribe has already accurately described what we discussed, and we can move on to the next topic. Additionally, you want to choose a scribe wisely, as they can drastically improve or derail that session time. As I mentioned earlier, technical scribe makes all the difference versus an administrative scribe who once again would just be typing in what I tell them to type in. They're able to follow along and capture the team thoughts rather than relying on the facilitator to dictate every single line. Also, a scribe is computer literate, can type, and is familiar with the PHA software being used will make a very large difference in the quality and the speed with which the PHA is conducted. Additionally, when you've trained an individual to be a good scribe, they can help a lot with the post-session reports, which my scribe does. They will help me out. It allows me to review the work they do, and so you essentially get a second look quality assurance before that report is ever distributed to the primary team. I cannot emphasize enough how much accurate PSI makes a difference during the PHA study, especially when it comes to P90s. We do spend a lot of time redlining, but what really derails our studies is when I have, the operations will come in and say, look, this is not how it looks in the field. We changed that 3 years ago. And then I actually have to send them with the engineer out in the field and have them redline. We typically will lose a day or two off of that. So I can't tell you how many times we've had stopped a process and later we find out the drawings are inaccurate and essentially the study is now obsolete. That requires huge costs in both time and team efforts. So we recommend doing it right the first time. When you have a large PHA with case and design studies, it gets increasingly more difficult with managing various inputs and keeping everyone on the same page. Additionally, oftentimes side conversations arise in these situations where important feedback isn't communicated well with the entire team and the critical discussions may be lost. We really recommend limiting the team to the necessary participants and limiting those side conversations, and then calling upon outside resources and subject matter experts for specific scenarios where additional expertise may be warranted. We recommend holding the LOPA, which is the layer of protection analysis. I'd mentioned that before. If you have some significantly high hazard scenarios, a lot of times you want a second look. Because I said before, this HAZOP is a qualitative study. But if this is significant, the layer of protection analysis really takes a look at those safeguards the team relies on and make sure they're going to be there when the team needs them most. And so you want to bring in LOPA, layer of protection analysis, as a second check on some of your high risk scenarios. For that reason, we typically recommend having that LOPA after the HAZOP conclusion, as LOPA employs a somewhat different methodology. The teams often get caught up in the nuances of the different methodologies. Additionally, we will want a controls engineer in the room, and so since we don't necessarily need them for the whole HAZOP process, this frees them up during that qualitative set portion of the study and then brings them in the LOPA portion of the study. It's just a better use of resources to wait until the end to conduct that LOPA with the necessary teams present. That being said, I have worked for certain facilities that prefer to do the LOPA on a case-by-case basis. The second you come up with that high-level event, something that's like a fatality or an off-site impact, you'll typically do the layer protection analysis right there and identify any additional safeguards that might be required, or use the LOPA to reinforce the team's assessment that perhaps it is not a significant risk scenario. Additionally, oftentimes teams change their minds on severities and the credibility of certain scenarios. So that, once again, that's one of the reasons it's a little harder if you do the LOPA on a case-by-case basis versus getting the entire HAZOP done first and then applying the LOPA at a later time. We want to ensure the roles and responsibilities of who is providing which expertise at the beginning of the study so that everyone is really on the same page. Some things to delegate would include that the engineer is in charge of capturing P90 red lines, and operations is in charge of checking the car seal list valve to make sure that it actually matches what's in the field. We want to make sure that each initiating event is only discussed once with all potential hazards listed for that initiating event. It gets very confusing when unique initiating events are duplicated for different deviations and each have a different hazard identification. Initiating events listed should be specific and credible. This is also going to help during the LOPA phase to assign initiating event frequency, ensure that team members are properly trained on methodology being employed so they stay engaged and can productively contribute to the conversation. We are Coming to the close of this presentation, and so what I want to discuss next is just the post-session documentation. That record of that study that you spent so much time and effort on, and making sure that it can be referenced and used at a later time when needed. You want to ensure that the completed PHA Pro, PHA Works, whichever software you're using to record, is complete and includes all the equipment used within the process. This includes interconnected processes such as utility system. You want to ensure that the consequence description is concise and clear when someone can understand the thought process 5 years later. Once again, even 6 months, 2 weeks, a month after concluding these PHAs, the team can come back and revisit the scenario, and it actually is difficult to remember why you made the assessments you did. So you really want to make sure that those consequences are developed properly so that maybe a different team, or once again, 5 years from now, it is most likely going to be a completely new team who are going to review and revalidate your work, and you'd like to make sure that they can understand the thought process that went into that analysis. It should be clear where the ultimate consequences, personal impact, an environmental impact, a business impact, etc. A scenario should never be left at just overpressure of the vessel. It's incomplete. It doesn't include whether loss of containment has actually occurred. You can pressure up a vessel, but if you stay within hydrotest threshold or within a very small amount over MAWP, that does not mean you're going to have a catastrophic failure. So you really want to make sure the consequences that you developed and detailed in the study say, hey, look, we overpressured this vessel, we blew out a flange, we blew out a coupling, it wasn't that significant overpressure, but now we have material coming out. On the other hand, if you overpressured, and a lot of times the number we see is 3.5 times the MAWP of the vessel, that's a catastrophic failure. If it is a light hydrocarbon, that is going to be widespread. There can be a significant impact from that event. You want to make sure that the future team reading this understands your assessment, how you came to the conclusion if you did say this would be a high-level fatality-based event, or based on the team analysis if you felt it might be an injury. Typically, you want to detail what kind of loss containment occurred. As I mentioned, the point is to be able to use this document for the next 5-year validation, and so we want to ensure that the scenarios identified and evaluated are clear and will make sense to the next team. It is incredibly important to ensure that similar scenarios are ranked consistently. Too often I come across discrepancies, and so it's important to review the risk rankings during post-session documentation to try to catch those discrepancies and clarify with the team before making changes to the documentation. A lot of times an initiating cause in one unit will impact the downstream unit, for example, tank farm, right? We're always sending stuff down to the tanks, and that might not necessarily be the unit we're covering the PHA. However, we caused it, we own it. So there might not be enough adequate resources available for proper evaluation at the time of the upstream PHA. So a lot of times facilities want to put together a system so we can catch those out of boundary limit scenarios and track them accordingly, make sure that you're evaluated in the future downstream unit PHA. So going back to the tank farm example, if I'm sending, high temperature material from a crude unit or something like that to a tank farm, I don't have the tank operator in the room with me typically. I have the crude unit operator in the room. So what safeguards are going to initiate, how the tank farm handles it, is not something that we have the expertise to properly evaluate. Now we could, take a break from our PHA, bring in the right engineers, bring in the right ops personnel, but a lot of times that's going to really drag down our study. So what we try to do is make a recommendation or a note or follow-up item, so when the tank farm does their evaluation, we go, hey, look, we found a cause in our PHA, we can send you some hot material, evaluate it with the proper expertise in the room, and come up with a good assessment. You want to make sure that the recommendations are written as open-ended to allow for closure by another solution. The purpose of the study is for hazard identification and not necessarily to solve all the problems on the spot. You want to provide some options for closure as helpful, but you want to be careful with thou shall recommendations that lock the engineering group into only one solution. Once again, engineering is not something you do in 10 minutes or 20 minutes or even a day. This can take months of work, and if a better solution is found, that's what should be done. And so you want to be able to allow those recommendations to the response to basically say, hey, we looked at the team's recommendation, there was a risk identified, we decided to do this, and it is going to meet and lower the risk because of X, Y, and Z reasons. We also don't recommend adding the word consider at the beginning of the recommendation because too often it is closed by considering the options and then determining that the current configuration is adequate. That's kind of a running joke. You say consider adding a safety rated valve for this particular scenario. And of course, someone comes along and says, I considered it, I'm not interested. Obviously, there is a risk there. The team identified the risk both legally and if there was an actual incident and that recommendation closure was read, it would not work out well for the person who made that determination. From our perspective in the PHA, we just simply try to avoid it in the first place. We don't say consider doing it. The team comes up with some ideas, we put them in there, and once again, if the engineering team, after the conclusion of the study, comes up with a better idea, they can use that to close out the recommendation. It's the PHA's job to identify whether or not the current configuration is adequate, which is why a recommendation was made in the first place. So if we thought there was a high risk, someone else does not get to come along once again and say, I considered it and I'm not doing anything. So verbiage should be things like, mitigate the overpressure hazard. Options include, but are not limited to the following. And so then you'll give some lists that the team comes up with. Once again, that can be overridden by the downstream engineering team. Additionally, there are parking lot items and follow-up items that are made during the study. So I said before, you want to have subject matter experts and people you can call on for more information. A lot of times, you reach out to them in the study, maybe they're not there, they don't answer the phone, so you make what's called a follow-up item or a parking lot item. And typically you'll then get that information at letter time, come back, review the parking lot item or follow-up, and then finish the scenarios. You really want to make sure that those follow-ups are done before the end of the PHA. If something is not concluded, we basically have to make a recommendation that then in turns and tells someone else to go do our work. But it was the PHA team's work. We should have been able to do that before the conclusion of the PHA. It dilutes the purpose of the study when follow-up items can't be addressed. They become regulatory-driven recommendations. I've been in refinery leadership meetings where those items were not concluded, and the leadership team does not look at that kindly. They make the point I just did. You're the experts. How did you not? Why did you not know whether or not that relief valve was sized for the case? That is literally what your job was to do. We want to ensure that PHA recommendations are typically only made for risk-driven and justified hazards. Other items that are not necessarily risk drivers should be captured as improvement ideas so that they're not looked at as regulatory-driven items. So the reason I say that is if we not need to lower a risk, that's a big deal. You want the regulator to be able to come in and say, hey, look, we identified this risk, we made this recommendation, and it was identified and closed out by the facility using this particular method or this particular instrument. On the other hand, from a regulator's perspective, if we made a recommendation, there's a risk. So if instead we made some sort of recommendation that might make operations jobs easier, something that might make the engineering team's job easier, but there's no risk associated, you don't want to track that in your regulatory driven items because once again if at a later date someone says, oh, there's not a risk, we don't need to do this, and they don't do it, well, the regulator is going to come in and say, hey, you had a recommendation, you didn't do it, that's not okay. So you want to make sure that you are primarily using your PHA to identify those risk drivers, and otherwise just put any sort of improvement ideas in a separate document, provide that to operations who can then do this item if they decide they really want to do it. Just keep the focus on high risk items, help prioritize these over maybe other nice to have items. Um, uh, any issues with the PSI documentation, so not just the PNIDs, the CNEs, the seismic studies, anything like that should actually be captured as a regulatory driven item. Those are, once again, within the words regulatory driven, it means if they're incorrect and you get audited, there's going to be an issue. So we want to capture them in the PHA. They're not nice to haves, they're things that the facility needs to do as part of the overall recommendation structure. So that concludes today's overview of the HAZOP and LOPA process. Obviously, this is a questions page, but this is a video tutorial. So if you really do have questions, reach out to me via my email, john.johnson@nebulasafety.com. I'm happy to talk about these subjects, to discuss any things you need clarifications on, anything you want me to expand further on. And of course, if you have ideas, certain PSM, certain RMP related subjects, certain safety subjects, environmental topics, and you would like to see a webinar on this in the future, please reach out to me and let me know. I am happy to record these webinars. I'm happy to disseminate this information. So like I said, questions or comments, please reach out to me at the email address below. And thank you very much for attending.